We'll be looking at some of the applications of ultrasonic waves. So the first one we'll be looking at is time of flight. So assume you have a block of metal and you want to find out whether it has any cracks or flaws inside it. So the metal is most probably going to be used for something, for some construction or some other purpose. So breaking it open and seeing is not an option. You cannot break the metal open to see if it has a crack or not, because that defeats the purpose. So without prying into the metal, you want to see if it is a solid metal or it has some crack. So that is where we use this concept. So, and also it is used in oceans when you want to go down to a certain depth of the ocean to, let's say, pick out an oyster, a pearl, or some mining or something. You don't just take a submarine and go all the way down and then figure out the depth. You want to know beforehand at what depth your target is, and then you will be appropriately equipped and you will go down. So that is one another application. So basically, to find out the depth at which something is located, if it is located at all. How this works is, so I'll explain with the analogy of a metal block, but you can extend the same to the ocean example also. So you assume this is the block of metal and there is a crack somewhere here. So I put the transducer here, and then do we have an image? No, okay, never mind. And then I make it generate ultrasonic waves. So if there is no crack, the ultrasonic wave travels all the way to the bottom of the metal and it gets reflected from there and comes back to the transducer. Now if there is a crack, it travels up to the crack and gets reflected there itself and comes back. So there is a time difference between this wave and this wave. So if all your waves are coming back, reflected waves are coming back at more or less the same time, you can say, okay, everything has hit the opposite end and it's coming back, there is no crack. But if one of them came back quite earlier than the others, then you can identify that this one came earlier, meaning it didn't travel all the way to the opposite, meaning there is a crack. So that is how you identify that there is a flaw or not. Now, having identified that there is a flaw, how do you figure out at what depth it is? Now you know the velocity of the wave which you generated, like you know the frequency, and we just saw a method called acoustic grating which helps us identify the wavelength. So when you have the frequency and wavelength, you have the velocity, and you can measure the time taken for it to travel and come back. So you have V and T. Now the distance traveled within that time T is this distance D plus another same D coming back. So it travels 2D distance in time t. So using speed equals distance by time, you get this formula d equals bt by 2. Why is the by 2 coming here? Because it has to travel twice the depth, once in going down and again in coming back. So that is how you use time of flight or ultrasonic waves to determine the depth at which a crack is located.